Good evening, I am Mr. Ish. You are joining me for this video over here on parallelograms. As is always the case, the goal for these videos is always to provide relevant videos with the type of questions that you would expect to see on either a standardized or a non-standardized exam. And I mean the types of exams you might see in your high school or your college classes. The core subjects are always mathematics, so let's look at this parallelogram, which will fall under geometry topic. The first question is this: show that the area of a parallelogram is base times a height. We know that the area formula for a parallelogram is base times height. We know the parallelogram looks like this. And why is this formula base times height? Let's show you. I'll actually show you two ways that you can look at it to show you why this is the case. If you start with a parallelogram and you divide it such that you have two triangles, and the way you can show this doesn't have to be complicated at all. It can be something simple, algebra or geometry or whatever your approach might be. You make this dividing line over here and you've got two triangles, right? You know the area of each triangle is half base times height. We know that. Given that, if you're creating two triangles, you're going to multiply this by 2. Simply just by that, you'll get a formula of a parallelogram as base times height, because what you've done is line up two triangles and you've determined the formula base times height utilizing that. That's one approach. Another approach is start out with a trapezoid. You know what a trapezoid is, but make sure the trapezoid is symmetrical in all regards and that it is equal, such that you could divide it like this into 3 triangles. When you're seeing these 3 triangles, you know what you're looking at here in terms of each individual triangle having a half base times height formula for each triangle. When you are seeing 3 triangles and you're looking at 3 over 2 base times height, this represents the total area of this trapezoid. But what's the difference between a trapezoid and this parallelogram, which is made of 2 triangles, is the fact that this is one more triangle, or you can say this is one less triangle. If you know that each triangle has a half base times height area, and you were to take away that half base height, that area of a single triangle, because you know the difference between this representation and this, a trapezoid and a parallelogram is this has one extra triangle, and you remove that one extra triangle to end back at a parallelogram, you could very easily do all of this. You will have 3 base height minus 1 base height all over 2. You'll get 2bh over 2, and that will give you base times height as the area of a parallelogram. Utilizing 2 approaches, you can say these are logical approaches or geometric approaches, but they are indeed successful approaches, and you've answered the question this way. This should be a very interesting question. Calculate the area of this parallelogram where each side is equal to 6, and the fact that I have these notation marks here means each side is equal. If each of these individual triangles have 3 equal sides, and we know we're looking at an equilateral triangle, has 3 equal sides and 3 equal angles, each angle will be 60 degrees. If we were to blow this up a little bit over here, we're looking at something like this. Each of these is 60 degrees, 60 over here, and you know what you're seeing over here, 60 degrees. I may not be showing you a good representation of equilateral, but it is equilateral, and each of these sides is 6. I won't mark them all, but there's 6. What you can do now, you really have to understand you need a base and you need a height. You already have a base. This right here is your base, and we know it's 6. You need to extend this out and determine this height. But you know when you extend this out, you are creating a right triangle. If this right here is 60, this here is 60, and you've created a straight line, this must be 60 over here, because a supplementary angle is 180 degrees in total when you're combining it with the other angles. These 3 supplementary angles add up to 180. If this is 60, this is 90, then this here must be 30 degrees. And let's blow out this dotted triangle we've just created. It looks like this: 60, 30, and a 90. And this side right here, the hypotenuse, ends up being 6, because that's the side we're looking at right over here. And we've just created this triangle off that. If this is 6, we have a 30, 60, 90. We know we are looking at a trigonometric ratio 1, root 3, 2. The 30 degrees is opposing a 1, 60 is opposing a root 3, and then the 90 is opposing a 2. We will do this area determination here without a help of a calculator. How can we determine what these sides might be? Well, we're only interested really in this side right here, because this side right here represents the height. We already have the base, we need the height. How can we do this using ratio? we know that this side over here we're trying to find, we'll call that h, over its ratio side is root 3 is equal to 6, the hypotenuse, over its ratio representation. So you have actual sides divided by their ratio sides, and that gives you everything you need over here. 2h is equal to 6 root 3 and h is equal to 3 root 3. 6 root 3 divided by 2 is 3 root 3. So now we know base is equal to the 6 right here. We know height is equal to 3 root 3. All you gotta do is multiply these and you'll have 18 root 3, and that would be the area of this parallelogram, which is shown, and the question is done. And with that we end this video. Thank you for watching. Stay tuned. Have a nice day. Bye.